We're in this business actually for the purpose of actually helping people, clearly. But there's a strong part of us that also wants to do other things, and that is to innovate, as Josh said, or to educate, like this, or to sort of do professional development. And so research obviously is a big component of that purpose, other than just filling or helping people with their illness. So I'm going to give you a revision. I'm going to give you a revision, guys, on classification of study designs. And those of you who've in med school or are residents or registrars, this will be something you've covered before. Maybe you've fallen asleep at the back of the class while it's been happening. And it's targeted towards the clinical and applied part of studies that we undertake, so not lab-based research. And I've asterisked a bit that I'm going to spend a little bit more time on in the next 10 or 15 minutes or so. Now, brief background, I'm an epidemiologist, so I'm a clinical epidemiologist, and it took the pandemic for people to realize that we're not skin specialists. So there's ways that we classify studies. The first and probably the most common that you're familiar with is whether or not they're observational or interventional. And this just means that observational studies, as the name suggests, is that there is no intervention applied to the subjects you're studying. We're just observing them. And it's a little bit artificial because the act of observing can change how people behave. But in theory, it's purely observational. Clinical trials are the classic interventional study. There is another type that I'll come to in a minute or later on. But you're probably aware that clinical trials are the archetypal. The other way we could classify the study designs is whether or not they're descriptive or analytical. What does that mean? It pertains to the type of question you're asking. Descriptive studies are answering a question that is quite superficial in nature or unidimensional. It's describing a problem. Whereas analytical gets into cause and effect. So a descriptive study seeks to understand how common COVID is, for example, whereas an analytical study seeks to understand what are the risk factors for COVID. Does that make sense, guys? So as Josh said, there's a hierarchy of study designs that we go through that by and large give you a higher and higher sense or larger and larger kind of sense of evidence or strength of evidence, if you like. And we do consider case series and case reports to be studies, but they're not really. You know, it's incidental, you report on something that you've noticed is interesting, you can publish it, it's good, but it's not really a study as such, even though we do include it. Ecological studies are those that rely on population data. You don't actually recruit subjects into ecological studies individually. You just collect population data, so you compare infant mortality between Australia and other countries in Asia, for example. That's an ecological study. A cross-sectional study I'll talk about, because I've highlighted the ones that you guys starting relatively early in your research careers will actually be more exposed to or have more opportunities to undertake. And then I will talk about case control and cohort studies. I'm not talking about clinical trials, not because they're not important, they're critically important, but I think for a beginner's class that it's not a type study design without a lot of help that you'll actually undertake. So it's not something you're naturally going to drive yourself, at least early on in your career. The other way that we can look at classifying study designs is whether or not they're longitudinal. And longitudinal studies follow subjects over time, whereas non-longitudinal studies do not. Why is it important that we make that distinction between studies that are longitudinal and those that are not? Albert, why are longitudinal studies important, especially for analytical questions?
Well, yeah. Excuse me. So we have that time to obviously see, because let's say you have a medication, right, and you put it to the market, you don't have a long understanding about what's going to happen down the line. It might be for risk, for example.
Sure. I'm sorry, Albert. I shouldn't have picked on you. I just saw you and I remembered your name. Longitudinal studies. The most important factor of relationships between exposure and outcome is temporality. You might remember that. Causality is based on many criteria, the first of which is temporality. That is, one precedes the other. And with longitudinal studies, we have a preservation of this first criterion of causality, which is temporality or time relationships. Is that okay? So, there are other study types, systematic reviews with or without meta-analyses. You can undertake them. It would require you to upskill a fair bit, but certainly open to you guys to undertake. As Josh said, they sit right at the top of the evidence tree, by and large, in terms of evidence for causality. I will talk about validation studies. These are the ones that assess accuracy of diagnostic tests. They're qualitative studies which don't collect data other than in a very unstructured format for opinions, etc. And then there are other study designs that are way beyond an intro lecture like this one or intro talk. So cross-sectional studies, you guys have good opportunity to undertake these. So as the name suggests, that you select a sample of the population and you find some information that gives you some description of an outcome or a risk factor or some profile of interest. And for all intents and purposes, every subject in your study contributes data only once. There's no follow-up of people over time. Now, as a descriptive study, the key you want to ensure is representation or representativeness. If you're trying to describe something and make it reflect a larger population, then representativeness is key in this. So if I want to do a sample of how common smoking is among medical students, and I recruit 100 medical students to provide me that information, it'd be nice as much as possible that 100 students represents the larger group. Make sense? So here's an example. I'm using examples from my previous experience with medical student projects. You guys probably might be aware, I've come from Melbourne about a year and a half ago, so with apologies, my examples are from Melbourne. So John was in fourth year at Uni Melbourne a few years ago, and we did this study that looked at discharge summaries, and we took a sample of discharge summaries from the general medical unit and assessed each one for how common acronyms were, or shorthand, and we gave it a OMG study and we published it. You know, it's just to assess how common or how inappropriate, potentially sort of problematic shorthand or acronyms actually are. At one point in time, each person or each discharge summary was the subject, no follow-up at all of the discharge summary. I'm going to say case control study and then discount it. I want you to know what it is, but I don't want you to think of it as an opportunity for study, as something that you should grab for reasons that will come clear. The case control studies are largely historical. They provide an opportunity for us to look at risk factors for conditions that are quite rare. And the opportunity was there for case control studies because we didn't have to wait for rare diseases to come on. They occurred, we would recruit them to a study, and so that's in that situation, it was a convenience for us to undertake case control studies. To remind you, the steps are this. For a case control study, we define a case. It's typically a rare disease. We recruit a number of them, and then we match them to people without the condition of interest, and they serve as controls. Having assembled these two groups, we compare retrospectively what their previous exposure was to a certain risk factor of interest. And it's a retrospective study, cases versus controls. No follow-up of patients or subjects at all. So here's a purely hypothetical example. We've got cases, disease X. We've recruited 300 of them. We've recruited 300 people, controls without disease X. And then we've asked and went back in time to see what their exposure to smoking was as a risk factor of interest. And then I won't go through the maths, but essentially you derive this measure called the odds ratio, which gives you an indication of how likely the exposure increases the risk or the likelihood of the disease. So this study design used to be much more popular than it is now, because we've got opportunities now to undertake another study design using technology that trumps, I don't like using that word, guys, sorry, that overrides case control studies. And that study design is a cohort study. Cohort studies are better than case control studies, are sitting higher on the kind of evidence hierarchy because they're longitudinal. You preserve the temporality component, which is a key component of cause and effect, yeah? So case control studies were necessary in the past because cohort studies for rare conditions needed to be very large, or you need to follow them up for a very long time because you needed that kind of exposure to have enough cases, incidents of rare outcomes, correct? So cohort studies preserve that relationship in a temporal sense between exposures and outcomes. Notice the plural in this. Cohort studies are not limited to one outcome nor one exposure. You can follow up for multiple outcomes, whereas case control studies can only focus on one outcome, whatever the case actually is. Is that okay? So someone tell me, why is it now, based on technology, we don't need case control studies as much anymore? What is it about cohort studies that allow us to undertake them with far more ease nowadays?
Probably electronic medical records.
Perfect. Very good. What's your name, young man?
Oliver.
Oliver. Well done, Oliver. Retrospective cohort studies are cohort studies for all intents and purposes. The cohort structure is maintained. However, with data, as Oliver said, through EMR or other forms of data, we can now assemble cohorts after the follow-up is complete. Yeah? All the benefits of a cohort study without the time and effort and money required to assemble them and follow people up in real time because of data. Is that okay, guys? So retrospective cohort studies, by and large, are better than case control studies, which is why we don't see as many case control studies undertaken anymore. So here's an example. Amy was in 5th year, now at Monash, or back then she was at Monash. She did her honours and then did a PhD. She took all the cases for tonsillectomy in Victoria, in admin data, 2 million sort of records, and analysed these kids, they're all kids, as they followed up after their principal or index tonsillectomy, and then followed them up for readmissions afterwards. And she was able to assemble a cohort, essentially, a group of kids who had tonsillectomy followed up over whatever time, with the outcome being of re-hospitalisation. Every time they got re-hospitalised, we actually knew that. So we could assemble this cohort. Does that make sense, guys? So you have that opportunity because, as Oliver says, we have good data. You just need the ethics and the governance to access that data and obviously some skills to analyse it. So I'll move fairly quickly through validation studies. You might have heard of these before. We're undertaking new tests all the time. There's a PCR test for COVID that came out a couple of years ago. We need to know that they're accurate, yeah? That's validation studies. So essentially what we do is we take a group of people with a condition, or we suspect we're having that condition, we test on them, subject everyone to their new test, as well as the same group to a gold standard test. And the latter serves as the reference. The latter serves as this truth, if you like, of whether or not someone actually has COVID. And then you compare the results of your new test against this reference of whether or not they actually have COVID, for example. And these couple of slides I'll move through fairly quickly, but essentially in validation tests, you're testing for how accurate the new test is versus the gold standard reference. PCR versus, rat tests, or rat versus PCR, a sputum sample for cancer cells versus a CT scan or bronchoscopy with biopsy. There has to be a reference test against which we're comparing the results of the new test, yeah? And then there are 4 measures of accuracy, if you like. The first 2 are sensitivity and specificity. I won't go through each of these in detail, so much as to remind you this is study design and these are the outcomes that we're hoping to achieve. So sensitivity and specificity of the test refer to how accurate for a given condition, or if it's present or if it's not, how accurate will this test result actually be? The other set of tests is called the predictive values. And these come from a slightly different angle, and they say, if you have a positive test, how confident am I in this being truly positive? Or if I have a negative test, how confident am I in this test being truly negative? You don't have to know right now. Don't worry if you don't remember all these parameters. So far as all you need to know is validation studies are a good opportunity for you guys to do research, because we are assessing new tests all the time, aren't we? This is, however, an interventional study. We do intervene. We are changing people's circumstances predominantly because we're giving them a new test that we're assessing. So you will need ethics for this, as you will need ethics for every study, but you will need sort of proper ethics, not low-risk ethics. And then I won't go through this, but essentially you might have seen it before, and those of you at Uni Adelaide from second year or third year, you would have looked at receiver-operator characteristic curves, which gives you this kind of summary measure of how accurate a particular test is. So my last thing to say, guys, is those of you who are medical students, and it has to be the perspective of Uni Adelaide, obviously. I know there are Flinders students here, although I'm quite sure this will be fairly similar because they're generic comments. So we encourage research. You know, we want to build that culture of research among our medical students. And you can take it in a formal sense, like you can take a year off to do an honours. At Uni Adelaide's usually after fourth year. Or you could do it in a co-curricular sense, so not formal in other words, but you, like many of you probably are undertaking already, some work in your own time. You know, match up with Brandon, do a project in your own time, etc. It's not towards any sort of formal program or degree. Now, at the medical school in Adelaide, we're very conscious, however, of what a load you guys already have. And so here are the kind of things, and Ben and I and a few others, we're working on a policy for Uni Adelaide students about this. But firstly, if you're doing co-curricular research, you can't compromise your primary studies. Secondly, you need to have good supervision. Brandon or Josh, for example, strong sort of supervisor group. As Josh said before, you need realistic and deliverable goals. So if you're doing a co-curricular piece of research, clinical trials probably beyond more than you can probably chew, yeah? Small, circumscribed, deliverable. And you want some a priori agreement about what the benefits are to you and your partners. You don't want to argue about who's going to be the first author on a paper after all the work is done. Is that all right? So keep that in mind. Ask your supervisor, can I be the first author on this paper? And if not, find out where you would be, etc., and have some expectations of what the benefits are to you. The benefits of research, as you guys know, is to acquire some skills, is to make some connections, obviously, and obviously to promote, your cognitive development. And that brings me to the last point. Focus on skills, not on knowledge. Knowledge is cheap. Evolves all the time. You can get knowledge fairly quickly, fairly easily, but it's skills that hold you in good stead for the rest of your career, all right? Whether that's skills in designing a study, writing a paper, writing a research grant, or doing some data analysis, whatever that actually is, skills are what's important, okay? That's it from me, guys.